Hello, I hope everybody is able to hear me and see my screen. I will be talking today about how to migrate an existing application to serverless. So this is going to be a quick presentation. I usually take 1 hour, so I just took the best pieces of the presentation and to share with you today. So first, a little bit about me. I'm a developer advocate for AWS. I've been doing serverless since 2016, so quite early on, and I will share a little bit of my story on this first serverless project I had during this presentation. It's a little of a horror story, so it's fun. I also the host of a YouTube channel called Fubar, where I post 2 or 3 videos every week on serverless and cloud. So whatever, mostly on managed services and serverless, you can find their tutorials and interviews, so go and check it out. And if you have any questions after the presentation and you're not able to reach me through Slack, then you can always send me a message on Twitter. I have my messages open, so I'm always happy to answer there. So let's get started. As I say, I will be telling the story of my first serverless project in 2016, and that's the not that successful story. And then the other part of the presentation will be on a more successful story and the best practices you can follow in order to do a happy migration to serverless. So most of my experience on serverless is on migrations. It's very rare that you get to write something Greenfield, unless you're maybe starting on a startup, but in general, when you're in an enterprise or in a big enough company, you might have legacy pieces here and there that you might need to move. And also because of working in AWS, I get to hear a lot of experiences of customers doing migrations and how they successfully go through the whole process. So I will share 2 stories and I hope they inspire you a little bit. So first, because this is not a serverless conference, I want to give a brief overview on what I think is serverless. The first thing is that serverless is a methodology. It's not reinventing the wheel. It's doing things that bring business value to your stakeholders. So this is the definition that Jeremy Daly gives. Jeremy Daly is one of the influencers of serverless in the AWS space. If you don't know him, go and check his content. He has amazing newsletters and podcasts, so you can learn a lot out of him. And then this is Jared Short, another of the influencers in the serverless space, that he says, if the platform has it, use it. So this is when considering to build something new. Don't build it yourself. If the platform has it, use it. If the platform doesn't have it, then check the market. If it has it, buy it from them. If not, then try to rethink your requirements. And if you can't, then build it and own it. And that's something important, not reinventing the wheel and maximizing the value as much as you can. From the technology standpoint, something is serverless when it adheres to these 4 criteria. The first one, scales automatically. You don't need to worry about scale. Sure, there are limits. Everywhere there are limits, but those limits are more soft limits that you can always raise, and they're there for your safety, but you need to know them. But in the imaginary case, how serverless should work, and in general it works quite well like that. If your application goes viral, it should be able to take it. Then you pay for how much you use. That's basic cloud. No managing infrastructure. So in normal cloud, you don't manage hardware per se, but you need to still think about CPUs, hard drives, memories, and things like that. When you're doing serverless, you don't need to worry about infrastructure at all. It's an abstract concept. You just put your code or use different services without caring about it. And then high availability is built into serverless components. For example, if you're working with virtual machines, you might need to decide in which data center, or if you're using AWS, in which availability zone you're going to deploy your service, and you need to have a kind of a thought about how you're going to have your availability in your application. With serverless, everything is high available, everything is distributed within the region that you pick. So basically, when you're using serverless, you will end up with these little Lego pieces. You will have compute Lego pieces, you will have databases Lego pieces, you will have queues, you will have all kind of different managed services that you will put all together, and you will glue either with events that move forward, with APIs, with little bits of code. You will glue together and you will end up with something like this. Don't get scared. This might look very scary, but it's not. This is a social media architecture. And if you look at it, there is a lot of orange boxes. Those are lambdas. Those are functions as a service. Usually those represent quite small amount of compute. So this is a quite big system that is designed in a quite simple way. Maybe the drawing is not the best. I like to show it because it's a little bit impressive. But if you will looking at a traditional server application, you will see like boxes, but then when you zoom into the boxes, you will start seeing complexity like this. In serverless, you just get that box out, everything is a little bit more naked, more exposed, and that's why the diagrams tend to look a little bit more scary, but it's basic system architecture. So let's start with the first story, the not successful one. I'm very bad at storytelling. I'm already telling you the end. It was 2016, and I was working in this project. I was not in AWS. I was working in a company, and we were building a Netflix for cartoons kind of thing. The difference between our service and Netflix was that we were monetized on ads, like YouTube is. Like you watch some videos, you watch some ads, you watch some videos. When you have that type of monetization, then you need to be very, very minutious about your expenditure. Like how you're managing everything really impacts on how viable the project is. So it was 2016, this project has been running maybe for 3 years, and I was working there for 2 years already. I love the project, and we got this mail from the boss saying that our project was too expensive, we needed to do something about it. If not, they would close it. And we were like, no, I love this story, I love this place, I don't want to leave. So then we were free backend developers. We did what backend developers do. They tried to fix the code, made it more performant, we deployed. Nah, nothing helped. By that time, we knew a little bit Lambda here and there. We have heard the stories. I have been doing some side projects. And we were like realizing that we needed to re-architect our whole application, like to take advantage of the edge of the cloud and all the benefits of the cloud, because what we had were some micro monoliths in the cloud. They were running in the cloud, but they were just not really taking advantage. And when you have an application that had so many views like we had 6 billion views by that time, it was quite a big service, then you need to take advantage of the edge of the cloud. More if you're sharing static content like videos, image, and text, everybody was getting more or less the same content. So why we don't take advantage of that? So we started looking at that and how we could re-architect the application, and we found that serverless was the way to go. We told our manager, hey, let's do serverless. He said, yes, sure, do whatever you want. You are free, independent people. If you think that's the best thing, just do it. And then we started this journey without knowing much about this. So what we did, we started learning about it. We hired a consultant that came and trained us. We did a lot of training. So we were starting really, really well. We started creating, I think this is something I took from this project and I kept for a long time, doing this small, minimal viable product that we were validating our hypothesis in how this new technology could help us. So we were developing solutions on prototypes for our applications to validate, okay, if Dynamo can help us, can this really help us? Can using the edge really help us? And doing benchmarks on different solutions, and we were getting a lot of experience. But then we did all this nice work, and then one day we started writing code. We got some feature requests to the old service from the team. So we added those features in the old team. So our scope for migration started changing. Then we keep on adding code, and we did more new fixes, more scope, growth, and cheeky, and months passed and passed and passed and passed. And by that time, I think 9 months passes. So we could have a baby by that time. But we didn't have any code in production. So we started really well, really motivated. By the time the 9-10 months arrived, we were all tired, bored. We have a scope that keep on growing and growing all the time, and we could never catch up. So one day we decided to go to production. Yes, why not? And then we start pushing code to production and seeing how everything was failing very, very poorly. And yeah, finally, after figuring out that we were not having a proper monitoring things in place, that we have not good pipelines in place to go to production, that we didn't have really good ways to hand over the traffic shifting from APIs, that we didn't remember the code that we wrote 6 months ago, and we started rewriting code with new, like it was a mess. So don't do that. That's not a good strategy for any technology. Even if you think that your project is small, like we did at the beginning, we thought this is small, it will take us a few months, and then we start coding. Don't do that. Follow the story number 2 strategy. That is the one from one of our customers, Comic Relief. This company is a company from UK, and what they do is they take over the television from one day. They invite artists, they invite humorists, and they take over the TV, and they take donations from people. So usually in one day, they get most of the traffic, and they can get peaks of 350 donations per second. It might not sound a lot, but donations are not requests. They are more than requests. You cannot lose them. You cannot duplicate them. You need to treat them very careful. So every donation is very, very important. So in 2016, they also started the migration process. They have a similar story than us. They started with some monoliths or little servers, one for their content, one for something, and then one for the donate. The donate is the most important service that they have. So when the day of the event came, they start putting servers, so they are able to take the load. They start setting up everything, and it took them many weeks to get everything set up in order to have one day support of these IT services. And then when everything finished, they put everything out together and they closed the shop. So they could not take donations through the whole year. So the idea is to migrate that one. So how they did? Well, they have two options. They could start with the least critical part of the system, or then they can start with the donation service. Well, they started with the least critical part of their service in 2017. They started migrating the first bit. It's a photo gallery. Nobody really cared. It was something small. They could test and gain confidence. In 2018, they migrated more and more pieces out, and they also start creating a framework of shared components. So in 2019, they migrated that donate piece. And now they were very confident to go and migrate that. They have the best practices in place. They knew what they were doing. They have tested all their systems, their monitoring, their CI/CD. They knew all the technology very well. So they feel very comfortable to migrate. And if you want to see the architecture, that's the link. It's a very resilient architecture, so no donation gets lost in the way. And the best part is that it's up all time. They don't need to set up anything special for the day of the event, because it can scale, it can take the load on the day of the event, but also it can scale to 0 when nobody is using it. So it's pretty cool architecture, and it's a great use case for serverless. And I think these numbers are pretty impressive. When they started in 2015, the yearly cost was $84,000 of their IT. And now in 2019, in March, their yearly cost was $5,400. So it's quite a big reduction on cost just by going serverless. And the serverless part costs $92. So most of the other costs are maybe from Drupal and things like that. And the cool thing is that they have everything as infrastructure as code. They can repeat it anytime. So go and donate. The donations are always open for them. So you will be helping some nice kids that need that money. But yeah, let's go to the story again. So what they were doing is the Strangled Pattern, taking a monolith out in little pieces, or in the case of them that they have already this kind of microservices, moving one microservice at a time to this new technology. So I want to share with you very quickly 5 steps to migrate to serverless. First step, step 0. So there are 6. Step 0 is to do your foundational work. What that means, think about how you're going to structure your microservices. If you have a monolith and you want to migrate to microservices, use the reverse Conway maneuver, align your company, your organization to represent the microservices you want to have, pick your development tools, what is your frameworks, what are the different bits and pieces that you're going to use. You don't need to use exactly all the same tools everywhere, like your language or the frameworks that you're going to use, but you need to have a clear reason why you're not doing that and why you pick one tool. Use infrastructure as code from day zero. Infrastructure as code is critical for serverless and distributed applications. If you go to console, you will never replicate that again in the same way. You will forget, you will have errors, you will carry out bugs. So try always to go infrastructure as code first. Have automated CI/CD pipeline, as much automation as you can, even if you think you cannot handle the pressure of going to cloud automatically, try to do it. Usually it doesn't impact you if you do small changes. So it's a good practice to be able to deploy to production as fast as you can. And then this is a very important one, have a good monitoring and observability system in place, know your alarms, tune them up, tune your anomaly detections, try to figure out if you have tracing enabled and how it works for the cloud provider you have choose. So when an error comes or something bad happens, you are confident that your monitoring system will report back to you. And also, if you are not confident, try to later on in your migration process, try to test it out with some chaos engineering analysis. So now we can go to step one. If you have a monolith, try to find the seams of the code. So you start separating those services out and organize the code inside the monolith in order to be able to separate it. We had a monolith, so that's what I'm using the example of that. We have mini monoliths that were doing, they started as monolith and they microservices, and they end up like monolith because we were too lazy. So that's what I'm putting the step of monolith. But then if you don't have a monolith and you have a microservice already, you can start from step 3, that is starting to move your code to serverless gracefully. And these are some short express tips on how you can think about migrating to serverless to take the full advantage of serverless. First one is think about logical microservices. Every function doesn't need to be a microservice itself, and it doesn't need to adhere to the microservices rule, but a collection of functions and services like queues that are connecting these functions, databases, step functions, or workflows can be considered a logical microservice. A logical microservice is a collection of all these services together. They are sharing some kind of common domain. They are all going to be deployed together. So they are not independently deployed, but that will make your life easier and is more practical. And they share one database or one or many, and that database access is private to those compute or services inside that logical microservice. So if somebody from other logical microservice wants to access your database, needs to go through an API. Basic microservices rules. Then you need to use event-driven architectures to orchestrate your microservices talking to each other, and also to orchestrate how different compute pieces talk to each other. So this will help you to keep independent releases, make your system scalable, to have modular and replaceable code, to be able to maintain. So you can have one-to-one communication using queues, one-to-many using pub/sub services, or many-to-many using event buses. Depending on the problem that you have, you might need to use one or the other. For example, to connect one function to another, use a queue. And then if one day you want to replace one of the functions, it's very, very simple. And also you're not bombarding the function with a lot of like load. If you want to throttle them, you might have a connection to a database. So you can use the queues also to help you to leverage the amount of events that are coming in. But I like this event router or event bus way to connect microservices. In this way, you need to register to all the consumers or the producers. Whenever you have a new node in your service, you just register them to the event router. You create rules on how the events are moving around the router, and that's it. This is something very, very good for building very big enterprise applications. Even if they're not serverless, they're just microservice oriented. Then we will go to the orchestrate your functions with workflows. So sometimes you need to do some things that are transaction based and things like that. So you might want to use workflows. If you're in the AWS environment, you can use step functions, but that's depend on what you're doing. So this is Young Q, Serverless Hero, another influencer in the space. And he says orchestration within bounded context, so inside your microservice, and choreography that is event-driven between bounded context, so outside your microservice. So this is a really good rule of thumb that you can apply when you're thinking about the architecture of your microservice. And then replace what you can with managed services. Don't reinvent the wheel. If you have an authentication service that you have written yourself, try to replace it with something else, Cognito, Auth0, or whatever already there, so you don't need to write it yourself. That adds a lot of cost of ownership that you might not be interested in having. And then we go back to the next step, that is break up the database. If you have a monolith, now you migrated the code, it's serverless, but you might need to take out pieces of the database to create a new one. Or even if you have a microservice that is in a more traditional way, you might have an SQL database and you want to migrate to a NoSQL database to be more efficient, more scalable, or even to files. So think about what is the best way to have your data stored, and now is a good time to migrate it. And then in the next point is to migrate the APIs, either if you have a monolith to migrate to the new service, or if you have an existing service to shift the traffic to the new service without really disrupting the client. And for that, you can use something like an application load balancer, where you can say to test, for example, 90% of my traffic goes to the old service, and now 10% of the traffic goes to the new service. And I can do that until I'm confident that everything is good. And when everything is good, I can start migrating little by little more traffic. So then all the users are not exposed to the new service, and you can test and they don't suffer any downtime. And that's it. Basically, these are the steps, do your foundational work, move your monolith to the cloud if it's not, or to the same cloud provider where you're doing the serverless migration. Find the seams of your code if you have a monolith, organize the data layer in order to start breaking the database later. If you have a monolith, move the code to serverless to take advantage of as much as you can from the serverless architecture, break the database or migrate them to a more efficient than MySQL, SQL databases. They don't tend to be very performant on large scale. Break the APIs so your customers can now have the new endpoints without destroying the endpoints, and then repeat from 5 to 7 until you're done. And that's all the migration. And I think I'm right on time. It's like running a race. You can find me in all these links. As I said, my Twitter messages are always open for any questions. So yeah, thank you very much.